morning students, welcome to my channel Chemistry with DNA. I'm NAUMAN AHMAD and today we are going to discuss some of the most important topics of physical chemistry for BSc part 1. And today I have selected the most important topic, that is Ostwald Dilution Law. So let me write the topic. The name of the topic is Ostwald's Dilution Law. Ostwald's Dilution Law. This is the most important topic and very easy topic of BSc. What is Ostwald Dilution Law? We have discussed it in the previous lecture. Let us take an example of, let's take an example of any salt like A and B, and it is in aqueous form. So when it is dissolved, so of course it will be formed A positive cation and anion will be formed B negative. This salt, it can be salt, it can be an acid, it can be base, and weak. That must be weak acid, weak salt, weak base. This why? Because here the reversible sign shows that it dissociates into cation and anion. So from acid, from base, from salt, you can take any kind of substance in it. This is, and why it is weak? Because in this equation, this is unionized form. Unionized form is converted into ionized form. This is ionized, and the symbol reversible. This is reversible. This reversible arrow represents that it is a weak acid. This salt is a weak acid. So here you can get the best idea. Okay, whenever there is any salt, acid, base in aqueous form and this reversible arrow is present, you can say that it must be weak salt, weak acid, weak base, because it dissociates into a cation in aqueous form and anion in aqueous form. So you can get the best idea. So let's take the initial concentration. So initially C is the concentration, and for O it is 0 and for B it is 0. But after some times, at equilibrium, when equilibrium is established, this is a concentration. This now C stands for molar concentration, and alpha represent degree of dissociation. Here concentration is C is reduced by, concentration is reduced by degree of dissociation, like here C alpha and C alpha. Now the unit at after sometimes we can say according to law of equilibrium, K stands for concentration of product divided by concentration of reactant. So what is the concentration? Concentration is C alpha dot C alpha divided by concentration of reactant is C minus C alpha. So here further K represents, now see here we can say K, we can say take C as a common form here, so you will get, and here we the C alpha dot C alpha will be from C, here we can get the C common, so 1 minus alpha will be here. So C is cancelled with the C, so K is equal to C alpha square divided by 1 minus alpha. This is the equation. According to law of equilibrium, the equation is K is equal to C alpha square. So this is very, very important. Now let's discuss some important conditions for this. Condition number 1. Condition: when weak electrolyte is present. Weak electrolyte. When weak electrolyte is present. When weak electrolyte is present, alpha is very, very small than 1. So from this equation we can ignore. So K will be C alpha square. If you find out the alpha, so what will be? Alpha square is equal to K divided by C. This is another equation. Now here is square, you can take under root of it. So like this, and K. So this will cancel with this. So alpha is equal to K under root. This is the most important relationship in which degree of dissociation is inversely proportional to the square of molar concentration of electrolyte. So this is relationship number 1. And here, if, let me remove this one. If V is the volume, if containing 1 mole of electrolyte, if V is volume containing 1 mole of electrolyte, weak electrolyte or electrolyte, if so, that is you can say that concentration is equal to 1 by V, which is simply C 1 by V. And if we just put this value over there, just V, just replace it and place it in place of this. So this way alpha is equal to K into V. This is another important relationship. This is relationship number 1 and this is relationship number 2. So from this we can get the statement of Ostwald Dilution Law. So what is the statement of dilution law? Let me write it over here. It is very easy. So before that, let me write it again. What was the This was the statement number 1, and the second was this is second statement, from where we can get the best statement. In case of weak electrolyte, what is the statement? In case of weak electrolyte, degree of dissociation means alpha. In this case is inversely proportional to the square root of molar concentration, are directly proportional are directly proportional to the square of volume containing 1 mole of electrolyte. We can say 1 mole of weak electrolyte containing 1 mole of electrolyte. So this is the statement of Ostwald Dilution Law. From these two equations, you can easily understand, in case of weak electrolyte, degree of dissociation alpha, this is called degree of dissociation, is inversely proportional to the square root of molar concentration, and directly proportional to the volume, directly proportional to the square root and square root of volume containing 1 mole of electrolyte. So for weak acid, this Ka is what, and for weak base Kb, what is the value of Ka and what is the value of Kb? So here from this, alpha will be equal to Ka upon C, and for weak base Kb will be divided by the value of this will be Ka for acid and Kb for base. This is equation number 3 and this is equation number 4. So this was basically Ostwald dilution law. The statement is very important, this derivation is very important. It is one of the most important topics, but in very short video I just explained it. I hope you enjoyed the video. Again, there is any question you can ask in the comment section. Take a very good care of yourself. Assalamu alaikum.